All right, Shannon, can you hear me? Yeah. Oh, okay, good. Oh, for crying out loud. Okay, give me a minute to get set back up again because it closed out some stuff. So, all right, guys, give me just a minute. Looks like it's working again. Just give me a minute to get set up. Okay. All right. So, just to clarify, can everybody hear me now? Yes, great. Okay. Um, just to confirm, so I've got Joy, Shanna, and then one other name that showed up as a number. Can you let me know who that is? Is that the one last person in here? I'm just going to take roll. Sylvia. Thank you, Sylvia. So we're waiting for Sarah and Crystal to join still. Okay, we'll give them a couple of minutes. Let me go remind them to come back on. Holy Toledo. Sarah, thank you. Let's make sure, who else were we missing? Crystal. Let me make sure Crystal's coming back. I think that was Crystal. Just a minute, guys. Oh, I understand. So I'm glad you were able to get another one and all this craziness. I'm sorry that your computer died last night. Um, oh no, that's terrible. I'm so sorry to hear that. All right. All right. Well, that's fun. All these little technical glitches are so much fun. um, okay, Paula. All right. So I just want to touch base again really quick. I posted an announcement yesterday with the exam review, the instructions for taking the exam remotely using Honor Lock, and also the exam worksheet. For those of you that don't have access to a printer, that's okay. Just do your best to clearly write your work and keep it organized. I've just had a few that come in different order, and it's really hard to find where the work is and it's hard to read. So I highly recommend, if you have a printer, print out the worksheet. If you don't have a printer, that's fine. Just do your best to keep your work in order so that we can like I said, my favorite thing is being able to give you guys extra partial credit on the exams. So the more I can give you, the better. So the better your worksheet is organized, usually the easier it is to give you that extra partial credit. So before we get started going through the exam review, I just wanted to ask, does anybody have any questions about how, like the exam or anything that we've done? Like I mentioned on Tuesday, come ready with your questions. We have 2 class periods to go through the exam review. So I'm more than happy to take it slow if you guys want to ask questions throughout the class. So does anybody have any questions before we get started? No, not yet. Okay. What we're going to do, is do kind of what we've been doing, but I want you guys to feel really comfortable asking questions. So if you have a question, just type Q in the chat and I'll unmute you so that we can actually talk and you can explain your question. That way, hopefully anything that anyone's having confusion, we can get through pretty quickly. Did everybody get the review document? Yes, good. Okay, so I have it on the screen, but if you were able to print it out or have it in front of you for review, that's probably going to be helpful. So as we did before, these questions are going to be very similar to what you see on the exam. You guys have seen that now for the last 2 exams. And what you'll notice here is a number. That's the section, and then the practice problem number. So these are the same problems from the practice problems that will correspond to the exam problems. So just make sure that you're really comfortable with these problems to make your life a little easier for the exam. So we'll just start going through them one by one, and let me know if you have any questions, all right? So this first one here is 4.7, number 15. We have 1/9 minus 5/3 divided by 1/2 times 3/8. Now this one is dealing with order of operations with fractions. So I'm going to write it out. 1/9 minus 5/3 divided by 1/2 times 3/8. Now, let's all remember our order of operations. We have grouping symbols, exponents, multiply, divide, and add, subtract. So who here, what do you guys think we're going to do first? Are we going to divide? Are we going to multiply? We don't have any grouping symbols or exponents. So what do we need to start with here? Any ideas? Divide. Very good, Sarah. Remember, when it says multiply and divide, that means this whole section is what we need to do first, and we need to go left to right. So that means we need to start with this one. So we have 5/3 divided by 1/2 is what we need to do first. Remember what we need to do whenever we have a division for fractions, we switch it to a multiplication problem. So that's the same thing as 5/3 times 2/1. Remember, same dot flop. We multiply by the reciprocal or same dot flop. And when we multiply, we do not need to find a common denominator. The only thing you might want to do here is simplify early. You can or you don't have to. In this case, there's nothing to simplify. So we just multiply across. So we have 5 times 2 over 3 times 1, which is 10/3. All right, everybody okay there? All right, so that means that now we have 1/9 minus 10/3 times 3/8. Right? Because this, well, let me write this a little differently so you guys can see it. This gave us 10/3. There we go. Okay. Now we're still in our multiply divide order of operation because we still have a multiplication. So that means we need to do this part. So, oops. 10/3 times 3/8. Remember, that equals 10 times 3/3 times 8. Can we do any simplifying, or should we just multiply? The answer is, yeah, well, you could multiply, but we could also go ahead and simplify a little bit. So there's 2 ways to do this. If we were to go ahead and simplify, we could basically pull a 3 out of the top and the bottom, right? So that 3 divided by 3 is 1, and that 3 divided by 3 is 1. We could also pull a 2 out from the top and the bottom, right? 10 divided by 2 is 5, and 8 divided by 2 is 4. And that number, 5 times 1 is just 5, and 1 times 4 is 4. So that's a lot easier to multiply. All right, so we know that that is 5/4. Now, let's say I didn't know how to simplify that. I'm just going to write that 5/4 over here so we don't forget. Let's say that we didn't remember that part, that we didn't know how to simplify yet. Over 3 times 8. We would end up, we could just multiply. You don't have to simplify first. That's a shortcut. If it doesn't make sense to you or you have a hard time with it, don't worry about it. But it does make your life easier. Let's say we just multiplied across, then we have 30/24. Well, I look at that and I know they're both divisible by 6. So I would get 5, oops, that looks like an 8. 5 over, oops, gosh darn it. 4. So we end up getting the same answer. It's just two different ways of doing it. All right. So now we know that this whole, that part, that multiplication part equals 5/4. So this whole thing now boils down to 1/9 minus 5/4. So now what do we need to do? How do we do that subtraction? Can we subtract it just like they are? Lois, very good, Joy. We cannot. We need to find the least common. They need to have a common denominator. Exactly. So what are we going to do to find the common denominator between 9 and 4? Let's go ahead and use the division method. So we have 4 and 9. And remember, we do our prime numbers, 2, 3, 5, 7, ... So let's start with 2 because we got to go in order. And 4 is divisible by 2. So 4 divided by 2 gives us 2. 9 is not divisible by 2, so we skip it. We just bring it down. We can still divide by 2, so 2 divided by 2 is 1. So we're done on that side. 9 divided by 2, it doesn't work, so we can pull it down. So we're done with 2. Now we go to 3. 9 divided by 3 is 3. Carry that 1 down, and 3 divided by 3 is 1. So now our least common denominator equals 2 times 2 times 3 times 3, which is 2 times 2 is 4. 4 times 3 is 12. 12 times 3 is 36. All right? You guys kind of remember that? Ish, kind of? All right, so we're going to come back over here and write down that our least common denominator is 36. So in order to make these, we have to write them as equivalent fractions with the same denominator. All right, so that means this 9 we have to multiply by 4 to get 36, and whatever we do to the bottom, we have to do the top. This 4 we have to multiply by 9. Sorry, I'm like spacing out a little bit there. Sorry. 5 times 9 on the top then. Whatever we do to the bottom, we have to do to the top, right? All right, so now we just multiply across. So for that 4/9, we now have 4/36 minus 5 times 4 is 45/36. Everybody with me so far on this? Very good. Okay. Now that we have a common denominator, we subtract across the top and keep the same denominator. So we have 4 minus 45 all over 36. What is 4 minus 45? Does anybody know? Negative 41. Very good, guys. That equals negative 41/36. Are we done? Doesn't it usually tell us this one? Of course, I didn't write down the directions for it, but no, normally we have to convert it to a mixed number. So make sure you pay very close attention to what they say on the exam. So let's just go through how to convert that to a mixed number. So we have negative 41/36. All right, so we know that that's going to be some negative number, right? But we need to do the division, right? We need to do 41 divided by 36, right? Everybody okay with this so far? All right, so 36 goes into 41 one time, and when we subtract it, we get 5. So this equals 1 remainder 5. So that means our mixed number is -1 and 5/36. That's if it asks for it in a mixed number. If it's okay leaving it as an improper fraction, that would be our answer. Any questions about that one? Okay. All right. Let's look at the next one. The next one says simplify the complex fraction. Do you guys remember what complex fractions are? Anybody remember? Yep. What is a complex fraction? Remember, a complex fraction is when you have a fraction in the numerator and or the denominator. So that makes it a complex fraction. So it says simplify the complex fraction. How do we simplify this? Remember, this is saying this number divided by this number. So this is the same thing as saying 6 over 25 divided by negative 2 over 15. Right? So then we need to switch that to a multiplication problem. So we do same dot flop. Now that's a multiplication problem, we just multiply across the top and then multiply across the bottom. But I see some numbers that we can simplify a little bit. 6 and 2 are both divisible by 2. So I'm going to say 6 divided by 2 is 3. 2 divided by 2 is 1. 25 and 15 are both divisible by 5. 25 divided by 5 is 5. Negative 15 divided by 5 is negative 3. So now when I multiply across, I get negative 9 over 5. This is a way nicer number than this. Now, it didn't say it in these instructions, so if it does not tell you to convert it to a mixed number, you leave it like this. Now, if it tells you to convert it to a mixed number, then you need to do the division, right? And then do the, so let's go ahead and do that just as practice. We have negative 9 over 5. So you divide 9. We know it's going to be some negative number. 9 divided by 5 goes in one time with 4 left over. So this is 1 remainder 4. So this would be negative 1 and 4 over 5. So you just need to pay attention to what the instructions tell you for how to leave it the answer. Any questions? All right. So we have, the next one's 4.8, number 19. We have evaluate the algebraic expression for the given values. Make sure you simplify your final answer. So we are given 1/3 A plus 1/5 B, where A is equal to 2/5 and B is equal to negative 4/3. So in this one, the first thing we need to do is plug our numbers in. So we've got our A right here and our B right here. So this equals 1/3 times 2/5 plus 1/5 times negative 4/3. So the first thing we need to do is our multiplication. Remember, we have grouping symbols, exponents, multiply, divide, add or subtract. So we can multiply this in one step and this in one step because they don't interact with one another. So we just multiply across, right? We have 1 times 2 and 3 times 5. So 1 times 2 gives us 2. 3 times 5 gives us 15. Then over here we have 1 plus a negative, or excuse me, 1 times a negative 4. So we're subtracting here, right? So we have 1 times negative 4 gives us that 4. And on the bottom, we have 5 times 2, which gives us 15. So remember, now that we have a common denominator, we don't even have to find the least common denominator. So that equals 2 minus 4 on the top, and we keep the same denominator. We don't subtract that bottom, we keep the same denominator. So that gives us negative 2 over 15. And that answer is simplified. Any questions? All right. Does this, I can't tell. Oh, you like that one? Oh, good, Joy. I like it when they have the same denominator also. The next one we're going to do is 4.8, number 49. So we have 21A over 10 divided by 7A squared over 15. So what's the first thing I need to do for this what's the first thing I need to do for this problem? Right, we need to multiply by the reciprocal. We need to switch it to a multiplication problem. So we would say 21a over 10, same, dot, flop. 15 over 7a squared. So now we need to multiply across. So we have 21a times 15 over 10 times 7a squared. How do we simplify that when we have a in the top and a squared in the bottom? Does anybody remember? Cross it? What do you mean by cross it, Kim? Cancel out. Is that, yeah, I'm not sure what you meant by cross it, Kim. So maybe you could explain a little further if you want me to answer to that one. Yes, we need to start canceling some stuff out. So does anybody remember how we do that with these types of numbers? What I would do is write your numbers in the front. So we have 21 times 15 times a, right? All over 10 times 7 times a times a. You write out those factors. Okay. Oh, I see what you mean, like cross it out. I see what you mean, Kim. I'm sorry, I thought you meant like cross multiplication. No, that makes sense. You're right. Yes. All right. So what we do is we write that a squared as a times a. All right. So let's just focus on the variables for just a second. I have an a here and an a here. I can cancel those out because that's the same thing as multiplying by 1, right? A over a equals 1 regardless of what a equals. Okay. Now, what about these numbers? We can just cancel those out the way we've been doing this whole time, because remember, if we, gosh, I wish I could just cover up with paper. If we were just to look at the number parts, you do like this. Here's my paper to cover. If we were just looking at the number parts, we would just do some cancellation, right? We would say, well, 21 and 7 are both divided by 7. So that's a 3. Oh, excuse me. Gosh darn it. Probably confusing the crap out of you guys. All right, 7 divided by 7 is 1. 21 divided by 7 is 3. And 10 and 15 are both divisible by 5. So I would say that 15 divided by 5 is 3. And 10 divided by 5 is 2. All right, is everybody okay with me there? No, you can see the part I'm working on, Joy. I'm covering up the letter part. We're just looking at the number part for a minute. Does everybody see the number part, how we canceled those out? Yes, okay, so that's what we've been doing with the numbers, right? As far as the variables, though, we just did that same thing. So a over a, anytime you have the same variable over the same variable where there's no exponent like this, a over a, that's just equal to 1. So now all we need to do is finish multiplying out the rest of what we have left. So we have 3 times 3 is 9 on top, and there's nothing else on the top, right? Then on the bottom, we have 2 times 1 times a, and 2 times 1 is just 2, and 2 times a is a. So our answer is 9 over 2a, and that's as simplified as we can get. And you don't, when you have a variable in there, you cannot convert to a mixed number, so you just leave it as it is. All right, does everybody get that? Okay, good. Good. All right, so next we're gonna look at, let's see what we've got next. Solve each equation using the multiplication property of equality, check the solution. So let's look at 4.9, number 27. All right, remember, oh, helps if I actually write the problem. Negative a over 3 equals negative 6. Does anybody remember what that multiplication property of equality tells us? Anybody remember that? I wish I could see your faces right now and see the absolute, yeah, the absolute no, I don't know what you're talking about. All right. The multiplication property of equality tells us that if I multiply something to one side, I can multiply it to the other side and the problem stays the same. So if I multiply one side by 3 and I multiply the other side by 3, it's still the same problem. In other words, whatever I do to one side, I have to do to the other side or I'm changing the problem. Remember, that's the balance. And when they say multiplication property, We're just saying that's the multiplication. When we write out our steps for solving algebraic expressions, or excuse me, equations, that's like the step number, what is it, 3, okay? So what we need to do then in this problem is multiply both sides by a number to isolate that variable a. So what would I multiply both sides to get that a all by itself? 3x minus 3. 3. Now, I want to point out something. There's a negative here. So let's go ahead and multiply by 3. Good Lord, 3. So then this 3 cancels. So we have negative a equals negative 12, right? Are we done? No, because there's still a negative there. That a is not by itself. So how do I get rid of that? Very good, Sarah. Now I need to multiply by negative 1. That gives me a equals 12. Looking at this, if you had multiplied by negative 3 in the beginning, oops, I messed up somewhere. Oops. I'm an idiot. Guys, please forgive me. That was supposed to be a negative 3, not a 2. I wrote 2, and I don't know why I wrote 2. This is supposed to be 18. Do you guys see that? I'm sorry. Okay. Clearly, I left my coffee somewhere. That's the problem. I'm going to blame it on that. Okay. So if I had multiplied by negative 3 from the very beginning, I could have saved myself a step because that negative 3 would have canceled out that 3 and the negative, right? So just think about that. But if you forget it, that's okay. You can still do this extra step of multiplying by negative 1. Just remember that when we're solving for an algebraic equation, you have to have a all by itself, no negatives. Okay? Does that make sense? Okay, good. All right, so that was the number 27 there. All right, now let's look at 4.9, number 41. And we have 2/3 x minus 1/6 equals 3/8. Now, in the last one, we didn't have a ton of fractions. Do you guys remember what we do when we have fractions all throughout the equation? There was a step we could do before we start solving that can actually help us. Does anybody remember? Very good, Shannon. We can multiply both sides of the equation by the least common denominator of all 3 fractions to clear the fractions. So remember when we were back in section 4.9, we learned that when we have fractions in algebraic equations, there's 2 ways to solve it, to start it. You can either solve it and then clear the fraction at the end, which is what we did in this problem basically, because that was already at the end almost. Or you can clear the fractions before you start doing anything. And in this case, because there's fractions all the way across the board and it's kind of ugly and it'd be a pain to add and subtract and all that stuff, it would be easier to just clear all the fractions out. So the way we do that is we find the least common denominator for all 3. So let's say we have 3, 6, and 8. So what do you guys think? The division method? Or do you guys want to do listing multiples? Listing multiples? All right, so we have 3, 6, 8. So we have 3, 6, 9, 12. Anybody seen any multiples of 8 yet? 15, 18, 21. Oh, 24. I think that's where we're going to be. So we have 6, 12, 18, 24. There we go. 8, 16, 24. So our least common denominator for all 3 of those fractions is 24. So in order to then go there, we multiply this side by 24 and this side by 24. All right, everybody with me so far? Okay, I'm going to take the silence for a yes. If you have questions, thank you, Joy. If you have questions, remember, type a Q. It's like raising your hand in class or whatever. We'll just call on you then, okay? So now we need to distribute that 24 through. So we have 24 times 2 over 3 times x minus 24 over 6. Now, does anybody need me to show you how I get from here to here, or do you guys see that? If you want me to show you, I'll write it out. You want me to show you, or you see it, Kim? Okay. So when you have a fraction, 24 times 2 over 3x, I'll show you on this one. Remember, 24 is the same thing as saying 24 over 1. And we just multiply across. So then we have 24 times 2 over 3 times x. That's how I get that one, okay? Then, same thing for the other one. So then we have 24 times 1 over 6. Remember, that's the same thing as 1, and you just multiply across. So that's 24 times 1 over 1 times 6, which is just 24 over 6. Is that better? Okay, good. All right. So let's keep going through on that one. All right. So then on this side, the same thing applies. We have 3 times 24 over 8. All right, now we need to do a little simplifying, and this is how we're going to get to our whole numbers. So 24 and 3 are both divisible by 3. So we're going to get 8 over here and 1 on the bottom. 24 divided by 6, we already know that that's 4. So, well, I shouldn't write that on the bottom. That's stupid. That's 4. And then we have 8 and 24. So 24 divided by 8 is 3, and 8 divided by 8 is 1. So now when we multiply, we have 8 times 2 over 1, which is the same thing as 16x, minus 4. And then we have 3 times 3 on the top divided by 1, which is just 9. So that's our new equation. This is the same thing. That equation right there is the same thing as this equation. It is just written in a different way. So all we've done is multiply both sides by the least common denominator for all 3 fractions to get rid of all those fractions to make this a little nicer to solve. Now, so now we have 16x minus 4. 16x minus 4 equals, what is it, 9? 9. Okay, now we have this nice, pretty algebraic equation to solve. So we don't have anything to simplify. The first step we need to do is get this by itself. How do we get that 16x all by itself? Add what? $16x. You want to add 16x to both sides? Now, if we add 16x to both sides, what we're going to end up with is 32x minus 4 equals 16x plus 9. So we kind of end up in our same position, right? We still have x's and stuff all over the place. So but I'm glad you asked that because it helps us show it. We already have this on one side. So what we really want to do is get rid of that on this side. Very good. So, was it Shannon? Yes, we want to add 4 to both sides so that we can get rid of that term. Remember, whatever we do to one side, we do to the other side. So now we have 16x, these cancel, equals 9 plus 4, which is 13. Okay? Now that we've got the variable terms on one side and the numbers on the other side, now we need to get that x all by itself. How do I get that x all by itself? What do I do? Divide. Very good. What do I divide by? Very good. Great job, guys. You want to divide by 16 on both sides. That 16 over 16 becomes a 1, so it basically cancels. So now we have x equals 13 over 16. And it doesn't, I don't know if it says anything about It didn't say anything about, it's an improper fraction, but I just wanted to make sure and follow the directions. So, or this is a proper fraction, so we don't need to do anything. So now, in order to check it, you would go back to your original equation. So let's go ahead and write our original equation and check it. So what did we have? We have x equals, what did we say? 13/16, and I'm showing you how to check it because it is kind of an ugly one. So we have 2/3 x minus 1/6 equals 3/8. So we plug it back into our original equation. Notice we do not plug it into this equation because we've already done some work. We could have made a mistake getting to this step. So if you plug it into this equation, it's not going to tell you if you got the right answer. You got to plug it into your original equation. So we have to plug that x in here. We have 2/3 times 13/16 minus 1/6 equals question mark 3/8. So we need to multiply, but one thing I already see is that 16 and 2 are both divisible by 2, so that already reduces a little bit. So now we have 1 times 13 over 3 times 8 minus 1/6 equals question mark 3/8. So since this is a multiple of this, I just have to multiply. That's my least common denominator just on the left side. Right now, I'm only worried about the left side, okay? So let's come up here. And remember, this is just checking our answer to make sure it's correct. So now we have 13/24 minus 4/24, question mark 3/8. So what's 13 minus 4? That gives us 9/24 equals question mark 3/8. Are we done? Is that a solution or not? We're not done, right? So that means we can simplify this fraction. They're both divisible by 3. So it gives 3/8 equals 3/8. And that's true. So that means that this is the correct answer. Any questions about that one, guys? All right. And I know that one seemed like a long one. It really wasn't that bad. I just went through a lot of the individual steps to make sure it was really clear. All right, so now we're going to look at an application problem that involves multiplying and dividing fractions. If your answer is an improper fraction, rewrite it as an integer or mixed number. Make sure you simplify your final answer. I want to point something out. When we go through the practice problems, it tells you if it's a multiply, divide, or it doesn't say this one's multiply or divide, but you know we're in a multiply and divide section, and then there's an add and subtract section. The reason I want to point that out is on the exam, it will not tell you that. You need to get familiar with how to identify between multiplying and dividing, adding or subtracting fractions, or whatever word problems we're dealing with. So here, this is 4.10, number 11. So we're going to keep it up here so we can see as much as we can. All right. So this is looking at an apartment rental. Desmond Apartment Rentals suggests that 3/8 of your monthly income be budgeted for rent. If a potential renter earns $2,440 per month, how much money should she budget for rent? So if I want to know what 3/8 of 2,440 is, am I multiplying or dividing? Dividing. Why are you dividing? You do multiply. Enjoy, that's a common mistake to think you're dividing. If I asked you, what's half of 100? What's the answer? It's 50. That's because 100 times 1/2 is 50. And it's easy to understand that it's 50 without doing that multiplication. But if we were to say do 100 divided by 1/2, we would actually get 200. So that's the way you can check it. If you get an answer that doesn't make sense, let's say we went ahead and did that. Let's say we did 2, 4, 40 divided by 3/8. That's the same thing as 2, 4, 40 over 1 times 8 over 3, right? And that tells us we're gonna get a number way bigger than 2,440, right? Because of the way what we would end up with. Let me go ahead and do it real quick so you can see it. I wanna know, this is how you can know if you did it wrong on the test. If we were to multiply that out, we would end up with 19520 over 3. This is bigger, hold on. This ends up being over 6,500. And you know that 3/8 of that is not going to be 6,500 because this is actually less than 1/2. So you know you should expect to get a number that's less than 1/2 of this. So let's look at it again and do it as a multiplication problem. So what we need to do is to multiply by 3/8. Okay? This is multiplication. Whenever it's asking you for what, like if you want to know what fraction is of some number, you're multiplying them. Okay? So in this case, we have 2440 over 1 times 3 over 8. 8. And they're both, this is actually, we can reduce this down a little bit. 8 divided by 8 is 1, and 2440 divided by 8 is 305. So now we just have 305 times 3, which is 915. So 915 is a little bit less than half of 2440. So that's a number that we would expect to get. So you have to look back and think, does this answer make sense? If you do division by accident and you get a number that's way bigger than what you expect or something like that, then you know that you need to change it to a different type of problem. Okay? All right, let's look at the next one. The next one is bow making. So this is 410, number 15. So to make a bow, 3/4 of a yard of ribbon is needed. How many bows can be made from 18 yards of ribbon? Now in this case, we're looking for how many groups of 3/4 are in 18. So let's say we had this long ribbon and it was, let's say 18 yards. I'm not gonna do it all up because I can't do 18. But look at, here's about 3/4. There's a 3/4. And then there's a 3/4. And then there's a 3. So what we're saying is we want to know how many groups of 3/4 are in 18. So do you guys think we're going to get a number bigger or smaller than 18? Bigger. Very good, Shanna, because the number that we know that we're going to end up with more, because just looking at it right here, in this small group, we have more than more than the number of yards, because 3/4 is smaller than 1. So we would expect more than 18 groups of it in 18 yards. So remember, anytime you're looking for how many groups of something are in another bigger number, excuse me, we're dividing. So what we would say is we are trying to find how many groups of 3/4 are in 18. So we say 18 divided by 3/4. Now remember, we need to switch that to a multiplication problem times. So we do same dot flop. So that gives us 18 times 4 over 1 times 3. Well, 18 and 3 are both divisible by 3. So now we have 6 times 4 on the top and 1 on the bottom. So the answer is 24. Any questions about that one? Okay, remember, if you're looking to find a fraction of a certain number, that's multiplication. If you're looking to find out how many groups of a certain thing are in another number. That's division, okay? All right. All right, now we're looking into the decimals, which I know everybody liked better than the fractions. So we're starting now with 5.1, number 37. So it says write the decimal as a fraction or mixed number. Be sure to completely simplify the fraction. So we need to start, we have 8.4. Does anybody remember how we start this? No, okay. Well, we know that we have 8 is our whole number part. And then we have some fraction after that, 84 over 10. That's actually really good, Sarah. That's true. It is 84 over 10, and you could reduce it from there. But I will, you're very, very good, Sarah. Yes, very good. You were close. What I was going to tell you, and I'm so glad you wrote it like that. That's perfect because it is 84 over 10, but it's also 8 and 4/10, because this is our whole number part here, and then this is our fraction part. That 0.4, when we read it as 4/10, is 4 over 10. Now, it's not simplified yet because this part can be simplified, right? We can divide the top and the bottom by 2. We do not mess with the whole number part. We leave that alone. And so that equals 8 and 2/5. So the way you do it is you start by writing the whole number part as your whole number part of the mixed number, and then you take that decimal and you write it as a fraction. And you can read it 4/10, or if it was 0.52, that's the same thing as saying 52/100. So remember, however many decimal places here, that's how many zeros you have in your fraction, and then you need to simplify that fraction. Okay, any questions about that? Okay. Next, we're gonna look at how to round to a certain place. So we're on 5.1, number 69, and we've got 0.397, and it says round to the nearest hundredth. So the nearest hundredth would be this 9. We look to the number to the right, that's a 7. So that means we round up to 0.0. But what do we do when that 9 rounds up? That means that it rounds that up to a 10, which then rounds us up to 40. Very good. So even though it's saying round to the nearest hundredth, it still ends up rounding up to 40 because of that 9. Those 9s are tricky, so you've got to pay very close attention to those. Any questions there? No? Okay, good. All right, so now we have performed the indicated operation. So we're at 5.2, number 15. We have negative 54.87 minus 2.543. Yes, 0.40, Joy, yes. All right, so when we are subtracting or adding, remember this is the same thing as saying negative 54.87 plus a negative 2.543. So yes, you can check this in your calculator. I will not know about it. I'm fine with that. However, I'm going to show you. Remember when we have two numbers that we're adding that are both negative, you add them as if they're positive and then keep the sign. So in this case, we would say 54.87 and we would add 2.543. And notice how I added that 0 just to have a placeholder. So we have 3, 11, carry the 1, 13, or excuse me, 14, carry the 1. Our decimal stays in the same place, 7 and 5. And it's negative. So it equals negative 57.413. And it doesn't tell us where to round it. So you need to pay very close attention to the instructions on the exam about where to round. All right, any questions on how to do that problem? I'm sure everyone's like, oh, I'm just gonna do it on my calculator, so I don't even care what you're saying right now. Is that accurate? All right. Let's see what's next. Now we have a word problem, and we actually just talked about one very similar to this on Tuesday, I believe. So we're in section 5.2 here. Solve the following application problem. Recently, an ill patient had a temperature of 100.9 degrees. If the normal temperature of a healthy person is 98.6, how many degrees above normal is this patient's temperature? Are we adding or subtracting? What are we doing here? Subtracting, very good. So we need to take the normal and subtract out the patient temperature, right? So in this case, we have 100.9, subtract 98.6. Write that decimal down. So we have 9 minus 6 is 3. We're going to borrow a little bit, and that goes down to 9. That goes away. So we have 10 minus 8 is 2, and 9 minus 9 is 0. So we have nothing else there. So the answer is 2.3. So it's 2.3 degrees higher than normal. Oops, you guys couldn't see that part. All right, any questions about that one? Pretty straightforward, I think. All right, we're on 5.3, number 15. 32.8 times 0.3. All right, so again, you can check in your calculator, but one thing I want to point out, and we're going to do it by hand to show you, is how the decimals work. Remember to count your decimals for your answer. So here we're not going to put any decimals in the multiplication step. We're going to do 4, carry the 2, 3 times 2 is 6, plus 2 is 8, and we have 9. How many decimal places do I need to have? 2. Very good. We have 1, 2 here. So we go 1, 2, and we have a decimal right there. So the answer is 9.84. Remember to always count your decimals, okay? And did it tell us if we had a round? It didn't say to round, so you could leave it there. And here's the other thing. 0.3 is about a third. Remember, 0.333 is a third. So if I look at 32.8, I know the answer should be kind of close to 10. Remember we talked about using estimation to kind of check your answer, make sure it's reasonable. That's how you can make sure it's reasonable. I know that the answer should be about a third of 32 or about a third of 30. So we should be close to 10. With 9.84 is pretty close to 10. Any questions? All right. Let's look at 5.3, 41. Now it says multiply by a power of 10 to write the number in standard form. Do you guys remember how to do that? In this case, we have 1.2 million. So what you do is you write 1.2 times a million. So that's how you write out the multiplication. And then how would I know how many zeros or how to multiply this? How would I know what my answer is? Count the zeros. Okay, so remember, you started here at 1.2. You need to go over to the right, the same number of zeros here. So we're going to go 1, 2, 3, 4, 5, 6. So we got to go 1, 2, 3, 4, 5. So our decimal moved over there 6 places, and you need to add in filler zeros to make sure it goes over 6 places. So we went 1, 2, 3, 4, 5, 6 places. So that tells us our answer is 1.2 million or 1,200,000. So remember, if it's a bigger number than 1, then you count the number of zeros and you move it to the right, that number. So your decimal moves to the right, the same number of zeros here in that number. Any questions about that one? Oops. Okay. All right. next one is another application problem, everybody's absolute favorite. We're on 5.351. All right, last week, Bernice worked 32.8 hours and was paid $10.85 per hour. How much did Bernice earn last week? Round to the nearest cent if necessary. What place is the cent place? When it says round to the nearest cent, what place is that? Tens place? So if we had x, point x, x over here, hundredth, there's a D in there, but that's okay. Very good. It's this place. This is your hundredths, this is your tenths. So whenever it tells you to round to the nearest cent, you need to go to this hundredths place, okay? All right, so now that we know where we need to round it, first we need to figure out what number we're looking at. So we have Bernice worked 32 hours and was paid $10.85 per hour. So what operation are we adding, subtracting, multiplying, or dividing here? Multiplying, very good. We are multiplying. Think about this. I got paid $10.85 this hour, this hour, this hour, this hour, this hour, and we need to add it up 32.8 times. So we're gonna do 32 well, hold on. I like to put the bigger number on top. We're gonna do 10.85 times 32.8. So when I say bigger number, I should say the one with the most digits. So we're gonna go ahead and multiply, and we're gonna say we have 5 times 8 is 40, 64, so we have 68, carry the 6, 6, 8. We're gonna do 10. Actually, it's kind of nice, I can just erase these. Okay, 2 times 5 is 10, carry the 1, 17, carry the 1, 1, 2. And then we're gonna do, we have 15, carry the 1, 24, 25, carry the 2, we get a 2 and a 3. All right, so now we gotta add it up. 0, 8, 13 plus 5 is 18. 13 plus 5, right? And then we have 9, 15, oh no, 14. Oh wait, hold on. I forgot to carry that 1, didn't I? Carry that 1, so now we have 15, carry the 1, 5 and 3. How many decimal places do I need to have? Oops, sorry, you guys can't see that far down at the bottom, can you? There we go, sorry. How many decimal places? 3. Right, we have 1, 2, 3 decimal places, right? 2 here and 1 here. So we go 1, 2, 3. So the answer is 355.880, and we need to round to the nearest hundredth. Well, that's pretty easy, right? So that gives us 355.88. Any questions about that, guys? And we kind of expected that. This is about 33, and this is about 11. 33 times 11, or 33 times 10 even, is just 330. So we expected it to be a little bit higher than 330, so that makes sense. It's very reasonable. All right. Now we're going to go to 5.4, number 53, and we're given some a lot of operations where we really need to consider the order of operations. So here we have 2.1 times 5.2 minus 9.1 plus 4.2 squared divided by 0.2. All right. So order of operations, grouping symbols, exponents, multiply, divide, and add or subtract. We have all of them, right? This is super fun. So our first one we need to do are grouping symbols, right? We need to add 5.2 minus 9.1. Now, we can do this manually, but now that we're kind of going through many, many steps, and just for time's sake, I'm gonna go through and do that part in the calculator. So 5.2 minus 9.1. That gives us negative 3.9. multiply by 2.1 plus 4.2 squared divided by 0.2. Okay, so far? Well, we're done with our grouping symbols. Now we need to do our exponent, right? So we have 4.2. Remember, our base is all squared. That 4.2 squared, it's applied to all of it. So that's the same thing as 4.2 times 4.2. Make sure you don't just apply it to that 2. All right, so when we do 4.2 squared, we get 17.64. Let's go ahead and write the rest of our problem carries down. We have 2.1 times negative 3.9 plus. So now what do I do next? We're done with our exponents. We're done with our grouping symbols. What's next? Multiply, divide. Very good. So what are we going to do first? We can actually do these in the same step, right? We can do this on its own and do this on its own because they don't interact. Now, if you don't remember that, you could do one at a time. That's okay too. So we're going to do 2.1 times negative 3.9. So that side equals negative 8.19 plus, when I do 17.64 divided by 0.2, I get 88.2. So now we just need to do our last step, and that's adding, and we're gonna get 80.01. And let's see, I think it said around to the nearest hundredth. It does, and it goes out to the hundredth. So that's our answer. Any questions about that? Okay, good. All right, good. All right, let's keep chugging along. All right, so here we have the hourly wage. So here we're doing some application problems. So Lennon earned, oh, this is 5.4, number 63, by the way, for anyone that's going back to work on these. Lennon earned $497.82 for working 32 hours at a local thrift store. So now we're actually given the total paycheck and the number of hours. Find Lennon's hourly wage. If necessary, round the answer to the nearest hundredth. Now this is a little different than the last one. The last one we were given the hourly wage and multiplied it by the number of hours to get the total paycheck. Now we're given the total paycheck and the number of hours. So what are we doing here? What operation are we doing? Dividing. Very good, guys. We're going to divide that total paycheck. So we have 497.82 divided by 32. Now, again, you can check this on your calculator, or if you're strapped for time, do it on your calculator, but I am obligated to show you how to do it with long division. So if we have 32, let's go ahead and write this a little bit higher, actually. We have 32 divided into, what were the number of hours, or the paycheck was 497.82. All right, so 32 goes into 49 one time, right? When we subtract that, we get 17. Carry that 7 down. And that goes in 5 times. So you can write our decimal up there. Remember, the decimal goes right above the decimal in the number under the dividing bar. So we have 5 times 32 gives us 160. So we have 17 left over again. Bring down an 8. It's going to be another 5, 160. We have 18 left over. Bring down that 2, 5 again. And where do we need to round this? We need to round it to the nearest hundredth. So we need to go beyond that to the thousandths place to know how to round to the hundredths place. Remember that. We need to go out one more digit. So 32 goes into 182 5 times. That gives us 160 again. So here we have 22. We're going to have a 0. We need to bring that down. 220 divided by 32. What do we get? That goes in 6 times. We don't need to keep going. All we needed was that number to tell us how to round this number. So since that 6 is bigger than 5, we round up. So we know then that our answer that we are going to input is 15.56. So we would say that his hourly wage was $15.56 per hour. All right, any questions about that one? All right. Now we're going to look at how to convert the fraction to a decimal. Round any non-terminating decimals to the nearest hundredth. So here we have 5.5, number 9, and we have 7 1/4. So earlier we were looking at how to do a decimal to a fraction. Now we have a fraction to a decimal. Does anybody know how to write this as a fraction? What do we need to do? 1 divided by 4. Yeah, we need to do that. So we know the 7 is our whole number part, right? That doesn't change, but we need to figure out what the decimals are. So that means we need to take this 1/4 and divide 4 into 1. And how many? We had to go out to the hundredths. So that means we need to divide out to the thousandths place, maybe. We'll see. We need to write our decimal point up there. 4 does not go into 1, but 4 does go into 10 2 times. That gives us an 8. We end up with 2. Carry that down, that gives us a 5 with 20 with no remainder. So we don't need to go out any farther to see how to round it because there's nothing there. We know we would just get a 0. So 7 1/4 equals 7.25. All right. All right, now we are going to look at 5.6, number 15. We're given y squared minus 7x, and we're given these values. So we're literally just evaluating the expression where we plug it in. So let me write these over here. We need the x is equal to negative 7.2, and the y equals 0.8. All right, so we're just gonna plug them in. So here we have 0.8 squared minus 7 times negative 7.2. So we have 0.8 squared gives us 0.64 minus, and when we multiply this, we get 7 times 7.2, and we have a negative times a negative. So we're gonna get a plus 50.4. Now we add those together, so we have 50.4 plus 0.64, and that's gonna give us 51.04. Any questions so far, guys? Nope. How's everybody feeling with this stuff? Are you guys feeling okay? You guys have any concerns? Okay. All right, let's look at, let's see here. All right, so let's look at 5.6, number 31. We have 4.5 times 2 minus z equals 2 times z plus 1 minus 3z. And we're asked if z equals 2.37, oops, not 2.37 is a solution. Really quick, oops, let me just see. Okay. Here we are, okay. So how do we decide if that's a solution to the problem or not? We need to plug it in and see if both sides are equal. So we're gonna do that. We have 4.5 times 2 minus 2.37 equals question mark 2.37 plus 1 minus 3 times 2.37. All right, let me make sure I just wrote all that down correctly. 2 minus 2.37. Perfect. Okay. Well, Just making sure. Okay. So now we need to simplify on both sides. So first on the left side, we're going to do that subtraction. So 2 minus 2.37 gives us negative 2.3, or excuse me, negative 0.37. So we have 4.5 times negative 0.37 equals question mark. Here we now have 2 times, this is 2.37 plus 1, which is just 3.37, minus 3 times 2.37, which is going to give us negative 7.11. So we just need to keep going. 4.5 times negative 0.37, oops, 0.37 gives us negative 1.665. And then on this side, we have 2 times 3.37 gives us 6.74 minus 7.11. So we have one last bit to do. 1.665 equals 6.74 minus 7.11. That does not work out. Does it equals negative 0.37. So those are not equal. So this is not a solution. Any questions about that one, guys? All right. We are going to leave off there. Well, actually, I'll tell you what. Here's my question for you guys. We have 1, 2, 3, 4, 5 more problems. We have 5 more problems. I'm fine sticking on a little bit later, but my question is, would you guys like to still meet on Tuesday for Q&A, or would you guys like to use that time to study? Because if we finish these 5 problems, there's no more material to cover. And if you guys don't have questions, there's nothing to talk about. But I'd be more than happy to meet on Tuesday and we can finish this up, or we can just do a Q&A. You want to do a Q&A on Tuesday, Joy? Anyone else? Would you guys be interested in doing Q&A on Tuesday also? Yes? All right, then what we'll do, then we'll go ahead and wrap this up, and then we'll finish those other 5 problems on Tuesday and then do a Q&A. For any of those that like need that study time, just let me know. It's fine. I think that way it'll give you a little time to absorb the problems we went through. Some of these are also from module 13, which some of you guys have not worked the quiz yet. So it'll give you a little time to finish up that module 13 quiz and keep studying for the exam. So does anybody have any questions for me today before we peel off? No. Okay. Everybody, please finish up your module 13 quiz. All work, all quizzes must be done by May 11th. There will be no credit for anything done beyond May 11th. So today is April 30th. Your final exam is going to be the 7th through the 11th. You'll have to take it sometime in that window. Nothing can be done after the 11th. So I highly suggest you work on your quizzes before the 7th. I highly recommend having your quizzes done before that window for the final exam. And then for the final exam, I highly recommend diving in before the weekend, because I want you guys, if you're having a hard time or technical issues, I want to give you time to work them out. Okay, we will talk again on Tuesday. If you guys have any questions over the weekend, email me and I'll get back to you as soon as possible. All right, have a great weekend.